My name is Peter Coombs, and today's webinar is focused on how we can help you to gain the maximum benefit from using MicroDrainage to auto-design foul and stormwater networks within a CAD environment, as well as how to attract the increasingly important BIM outputs. I'm pleased to also have my colleague with me, Ludmila Fedeva, who will be helping join the webinar today. Ludmila is a drainage engineer with 8 years of both design and modelling experience in the UK and overseas, specifically in the Middle East. The webinar is scheduled to last for about 30 minutes, and we have a very large audience today, so thank you all for attending, and we'll see how we go with regard to answering your questions as we go along, and subsequent to that we will send out a frequently asked questions sheet so that we can share all the answers with everybody. For those attending the webinar for the first time, please note that you're all muted, but feel free to send those questions to us in the GoToMeeting message box that's on your screen. During this webinar, we will be showing you how MicroDrainage can complement your existing working practices. The intention is to fit within your existing work processes, but to make it quicker and easier. I've received a massive amount of feedback on how this is helping our existing innovative customers to become far more competitive globally. Their human resources are better utilized, such as CAD technicians, who prefer to work within the CAD environment. So teams are working better together, staff are more motivated, and they're more productive, and it's freeing up valuable time for the engineers to concentrate on the modeling aspects. It's also improving quality control with the ability to check crossings and conflicts between drainage systems and utilities at the design stage, as well as reducing the risk of any oversight during the early stages of the design process with regard to maybe missing out impermeable areas of runoff entering into the network. You'll see how visual representations will help the PM to carry out checks before submitting for technical approval. We want you to gain the maximum benefit of using MicroDrainage with the minimum of effort. Hence, we have developed the software such that you can now auto-design the storm and foul water networks within either full AutoCAD as well as Civil 3D. And we can support the versions of Autodesk products from version 2011 up to the current day, up to version 2015. The modules within MicroDrainage that I'll be using today are DrawNet CAD alongside the APT, Advanced Productivity Tools module. The DrawNet is used for the graphical interface and APT for the 3D capability. So let me show you what I mean with a live demonstration. So I've opened up AutoCAD, and from the open menu I've just brought in an existing drawing. And this drawing is effectively comprising of two phases. If you think of this dashed line as being the demarcation between phase 1 on the left, for example, and phase 2 on the right, you can see along the top ribbon toolbar that we've installed the DrawNet CAD option. Now this DrawNet CAD option loads in and it will enable you to work with MicroDrainage within full AutoCAD, as you're seeing here, or Civil 3D. So the same ribbon will apply to both. If I look at the subdivisions here, we can see that there's an aspect of site. So when I say site, I'm referring to information that is relevant to the overall project site. And within the site option, I can look at the Network Manager. And within the Network Manager, you can design from here a number of new stormwater networks, new foul water networks, or even new existing networks. And these could be major utilities like large gas mains, large water mains, etc. And that will enable you to do a clash detection at a later date. So you can see that what we have here are two systems. We have a stormwater network and a foul water network. And the units are in meters. Apart from the actual drawing, now you could work with a straight 2D drawing if you wish, but if you have the benefit of surface data, we can load in the surface data from that site option again. So I'm just clicking on the surfaces, and here you can see the easting, the northing, and the ground level, the surface level points. So X, Y, Z coordinates. Now we can load in that information if you're working in full AutoCAD from a range of sources. So if I click on the load and then the drop down, just to show you that you could use a PWF. Now this comes out of the PDS software, Land XML, so the XML formats from either MX or Civil 3D itself, and then you can use text or CSV files, as well as if you had LiDAR data from Esri ASCII, the ASCII file formats. In this case, I've used the PWF format and loaded in the information. The other options we have up here are to set up zones, so PIMP classifications. If I click on this, I'll just show you what we've done before. So basically, on phase 2, we've highlighted the areas of roof, and we're saying that you will get 90% runoff from the roofs. We've identified the areas of highway as closed polylines or polygons, and 80% runoff will emanate from the highway areas. We've also identified parking areas. The default, that area that is left, is deemed to be landscaping. So we're saying that you would get typically 25% runoff from the landscaped areas. And I'll show you this on the plan. So looking at phase 1, we've taken a very simplistic approach. And if I just hover over these polyline areas, this is where we've said initially when we've defined the pipe network, and now we're saying this subcatchment is running off into a particular manhole location. And I've just very simply said the whole of this area is 100% impervious and it enters into the manhole. However, on phase 2, I've applied those PIMP classifications. So if I hover over the houses to the eastern side of the site, you can see that we have MD UK PIMP zones colored in red. So the roof areas are deemed to be giving off the 90% runoff. If I click on or hover over the parking areas to the front of the properties, the drives, we're saying these are car parking areas with a certain runoff characteristic. And then we have the highways again with their own PR runoff. The rest will be deemed to be landscaping. Now the benefit of doing this, and it will depend on the nature of your project as to how best to set things up. So if you had a couple of large areas of highway and roof, then it would be, maybe this would be a nice way to work. You could just classify the roof and enter that runoff into a manhole, and you could identify an area of a road and put that into a manhole as well. So there are various options that you could work with depending on your preferred choice, basically. Now this particular polyline is now an area, a subcatchment area that I have said is entering into a manhole. And what the program will do, it will take into consideration the proportion of the highway, the proportion of roof, and the proportion of car parking, as well as the default landscaped areas, and then provide us with a net value. So just to show you that in MicroDrainage itself, sometimes it's kind of nice to illustrate that within MicroDrainage. So it's the same site. I haven't loaded in the drawing in MicroDrainage, but I have on here the various areas, those subcatchments that I'm talking about. And here's the subcatchment that I've just shown you. And if I right click and take a look at the properties of the subcatchment, we will see that you have a gross area of the polygon, highlighted now in red, is 0.197. It's zoned. In other words, we've had those different areas identified on the CAD drawing. And the net impermeable area is actually 62%. So 62% of the 0.197 is 0.122 PR value for that subcatchment, which if I drag the area across, you'll see there's a leader here. So it's entering the runoff into that particular manhole or node. I'll close the properties of that. The other options that I mentioned in the introduction that would save a lot of time and effort is looking at things like crossings and conflicts. So if you had those utilities identified on the CAD drawing, what we can do is set up a filter, and then we can run a crossings and conflicts matrix. So if I click on crossings and conflicts now, based on this particular model that I've already set, we don't have any utilities in there, but what I do have are stormwater pipes, foul water pipes. And on the right hand side, you can see that the program has now identified those areas of negative vertical separation is really what I'm concentrating on. So crossing conflict number 7 is between stormwater pipe 5001 and the foul pipe 5002, where there's a negative 218 millimeter. This is all in meters. So there's 218 millimeters of clash between the soffit level of one overlapping with the invert level of another. So we'd have to go into the program and we'd have to sort that out. How do we do that? Well, we can take a look at the network details. So I'm moving on now to the next portion. Two other things to point out here really in the network manager. You can load in a MicroDrainage file and you can save the MicroDrainage file as an MDX format from that same location, just to let you know. But moving on to the network details, this is where I would expand the network details. For those that are familiar with working within MicroDrainage, this will be a familiar sight to you, although I'm still in AutoCAD. So you can see that I would come down here and then start to overtype invert levels and pipe diameters to lock the pipes and adjust the level of the pipe to avoid those conflicts and crossings. The other thing is here, if you're starting off with your design, the design criteria that you need to design in accordance with is set in the network option. So you can see here that I've brought in an IDF, intensity, duration, frequency, rainfall profile based on the 2-year return period, and then I've set the design criteria that you need to design in accordance with. And I'm thinking of, what would be the ideal depth of cover beneath highways. Typically is where we're putting the pipes. 1.2 meters will give you the optimum design based on cost, and then provide me with a pipe of the appropriate capacity to convey the flow from those areas of runoff that I've identified, and provide the gradient of the pipe such that we would have self-cleansing velocity of 1 meter per second. So all that information will be used by the program to then design the appropriate pipe size and put it at the appropriate depth at the relevant gradient to comply with all of this. Moving on to the creation and editing side of things, how did we set these up in the first place? Well, if I come in here and then maybe delete a couple of pipes for you, so if I just delete this particular pipe, just highlighting it in AutoCAD, hit delete. Same again with the downstream pipe. Okay, so I'm working with the stormwater network. What I would like to do now is redefine those pipes. So I simply click on define pipe, and then I can click on the upstream manhole position. You may have a tracing of these provided by the engineer, and then give this work to the AutoCAD technician to then click on the upstream end, click on the manhole downstream, and then click on connecting into the existing network, the network that I've designed a little earlier on. And we've now reinstalled those 2 pipes that were deleted. Within AutoCAD, if I just escape from that command, I can click on this manhole. If I wanted to move that manhole across, that would be easy enough to do. What I find as being really beneficial here is if I just click and pop up the XREFs for you. Of course, what could happen is that the drawing itself could be updated. So what you could do is then reinstall and then reference the latest revision that the engineers or the technicians are working on, and that may well mean that you just need to move a few manholes around or delete a few pipes, install some more. You can work with the latest iteration to make sure that everyone's working from the same page. So manholes can be moved. We can insert intermediate manholes here as well, move things around. There's a range of editing tools that would help you to carry out those edits. Imagine you get a phone call from the contractor on site. We've moved something, we've had to change something. Open up the latest revision, carry out the edits, save the latest version, and then we'll move on to the outputs in a second. We can define PIMP zones. So this is how we set up those areas. And if I click on Define Pimp Zone for Phase 2, if you look at the bottom of the screen, we can choose the default, we can choose the roof, highway, parking. It makes sense to set up the impermeable areas, the roof areas, the highway areas, the parking areas, leave the rest as defaults as the 25% PI. You can display the drawn out properties for the manholes and the pipes, etc. by clicking on this option here too. We have the long section view. So if we take a look at what's been produced so far, just commit with the AutoCAD commands, and there we can look at all the long section information. So here are the pipes. If I just increase the number of pipes that we can see, again, for those folks that are working with MicroDrainage and haven't used the DrawNet CAD yet, you'll be familiar with these views that you get showing the long sections. The pipe invert, the pipe soffit level is being shown here. We can add in the branch lines. We can add in the optimum depth of cover by showing the pipe bounds. So if I click on the top toolbar here, you'll see a magenta line, which is the ideal 1.2 meter cover depth level. Sometimes the branch lines, these cyan blue circular pipes, these are the branch lines coming in. The topography from the branch line could force this pipe down lower and then drag the main line with it. This is what's happening here in this case. And we can see what we have in terms of pipes and the depth of water within the pipes by showing the cross section. So these are all circular pipes, single circular pipes, and this is showing you the proportional velocity of the flow within the pipe for this 2-year return period that I indicated earlier on in the design criteria. You'll notice that the pipes have been automatically designed with a variety of pipe diameters based on the runoff entering into the network. We can plot the long sections from here as well. So if I click on plot long section, I go from pipe 1 to pipe 1005, for example. You can include branch lines or not, and branch connections, or maybe click them off. The hydraulic braid line could be put on there, and we can fix the text to the long section. But say OK, it will open up another drawing for us. Just expand that for you, and then let's just grab and pan. So there's the long section automatically produced with all the relevant data extracted out of the program. I won't need to save the changes for that. Just wanted to show you how you could easily produce long sections. There are a range of annotation settings, so we can tell the program, if I click on annotation settings, what information to show on the plan. In this case, for the pipes, it's minimal information, but we could say, okay, show me the length of the pipe as well as the pipe number, for example, for all of them. So now what will happen is that all the pipe lengths will be shown. As you can see here, this first pipe's 30 meters, just over 30 meters long. We can look at the display settings, and from the display settings, if we look at the network settings, I can now adjust the text height from 2. It looks a little bit too bold to me at 2, so let's reduce the text height down to 1. And please indicate that pipe text parallel to the pipe, and then say apply. So now I've updated by reducing the text size but having the information parallel with the pipe. We'll do the same with the manhole details as well. The results are really helpful. You can see the plan view with your own eyes. We have the manhole schedules. So opening up the manhole schedules, this is the kind of information the contractor will need for his setting out information. I can expand that, right click, export to a variety of formats. So there's all the information required for setting out the manholes. If I click on the setting out information, this is enabling you to extract the eastings and northings. One of the benefits, again, by working within DrawNet CAD, you're clicking on a known drawing with coordinates that are set to your site, so you're picking up all the relevant information and providing that to the contractor. The other interesting areas are area summary. Now if I scroll up, this is showing you that we've got a PR, PIMP value of 100%. This is on phase 1. that simplistic method that I mentioned on the left hand side. And then as I scroll up, we're looking at the phase 2 networks. And right at the head of the system, you can see that we have zoned. So the PIMP type is as zoned. And you can see that we have the 4 different characteristic runoffs from the default, the area that's the gross area of that default netted down to the net impervious runoff in effect. The roof, the highway, the parking, all entering into pipe number 1, same for pipe 1001, etc. We also have a comprehensive help menu. So in the help menu, this is where we can select the module selector. And just to click on the options here and showing you that we're working with DrawNet CAD within full AutoCAD, along with the APT that unlocks the 3D capability within the program, and the engine that's running to carry out the design of this network, the hydraulic design, is the System 1 engine, using modified rational in the UK or the rational method for the overseas market. The program that you purchase is fit for purpose globally. We have a UK version and an international version within the same program. So if you're working on projects within the UK, it happens to bring in the rainfall data for you. Within the international version, we're working with the rational method and then full hydrographs when we get to simulation. So I hope that's given you a good indication as to how quickly and easily we can design a network, but also create the outputs that are required. If I go back into MicroDrainage and just show you the plan view, and if I switch off the areas, what I can do now from this plan view is I can save the DXF. I can save out the information about the network, and I've done one earlier, say called 3D BIM, that I'll load into AutoCAD Live. If I just save this out as a sample, slightly different job, but I wanted to get this dialog up for you to show that what we can do is we can export all the layers or just the visible layers on the drawing within MicroDrainage. And this is where we can identify not just 2D lines and circles, but click on the 3D, the cylinders and boxes, to export those 3D entities out of MicroDrainage, which we can then read into Civil 3D, and then you can set up meta tags within Civil 3D to add on the thickness of the manholes, the concrete surrounds, etc., etc. You can set up a library to then have the external dimensions as well as the internal hydraulic dimensions associated with the networks. And this is where the real power comes to play. So if I come across here and now just load in that earlier drawing, so I just want to open up the 3D BIM drawing. Here we are, it's loaded in, and if I just move that, oops, if I move that up for you, okay, and then just zoom out a little. So basically, what I'm looking at here are all those pipes and manholes, and from this 3D BIM export, I'd also run to create flooding on the surface. So I've said save out the visible layers, including the flooding coming out of these manholes, as well as the 3D entities. Now at the lower level, you'll see that we have the text. So the text is all down at like 0 datum, and then the 3D entities associated with the pipe network, the manholes, the pipes, etc., etc., they're all shown here. So I really hope that this overview has helped you to appreciate how you can auto-design foul and stormwater networks within the CAD environment. This will complement your existing working practices. So this is familiar territory for you. We're just providing you with the tools within AutoCAD Civil 3D to now carry out that design work more effectively. And this will help you to hit the deadlines more easily, as well as generating all of the outputs that you're going to need to potentially now gain swifter technical approval. You've got the plans, you have the long sections, the schedules, etc., all to gain swifter technical approval from the authorities. I hope this will also enhance your QA and enable you to market yourselves as being at the forefront of sustainable drainage design by using the latest industry standard technology. I'm going to upload this webinar as a video onto the website. We'll produce a frequently asked question fact sheet, and thank you all for the many questions. I've never seen Ludi type so fast in her life. And we'll send out a very short survey to obtain your feedback so that we can enhance your experience on future webinars that will start running again in the new year in 2015. So it'll also enable you to request a CPD certificate for attending this event too. So Ludi and I would like to thank you for listening and for participating, and we really did welcome all your questions, and thank you for that. Apologies if there's a slight delay in our responses. Unfortunately, I'm going to be going away on holiday very soon, so if you'd like to obtain a quotation to purchase a suite of software or to add the relevant modules onto your existing MicroDrainage suite, then either ring the office or email uksales@xpsolutions.com, and the team will be able to help. If you would like to install the DrawNet CAD into AutoCAD up to version 2015 and all Civils 3D, then please go and raise a ticket on the portal or email uksupport@xpsolutions.com, and we'll help you with that. And meanwhile, I, along with all of us at XP Solutions and Ludi, would like to take this opportunity to wish you and your families season's greetings and best wishes for a healthy and happy new year. Have a great holiday season, and I look forward to seeing you again in 2015. Take care.